Hey guys, Mr. Yaisley here. So we're on to lesson number 23, which is all about identifying an arithmetic sequence from a graph. So they've given us these graphs here, as you can see, and they have shown us some points on this that represent an arithmetic sequence that's going on. So what we're trying to figure out is, what does it represent? What is it telling us? What's going on? So when I look at this graph, what I like to do is I know that the x value, or also known as the n value here, right, that represents the terms, or what term it is in the sequence. So this point right here was the first term. This point right here was the second term. This was the third. This was the fourth. So that really doesn't tell me anything other than where that term was in it. Now, in terms of the y coordinate, or also known as the a of n coordinate, right, this tells me what the actual number is that was in the sequence. So this says the first number was 15, the second number was 12, the third number was 9, and the fourth number was 6. This is what we talked about in lesson number 22, so just as a reminder. So when I go in and look at this, what I like to do to determine what's represented, what's going on, right, is I like to go in and see, all right, well, what's happening? When I went from 15 to 12, what happened? Well, to go from 15 to 12, you have to subtract 3. So from the first term to the second term, I subtracted 3. Well, what happened from the second to the third? Well, I went from 12 to 9. Well, that means I had to subtract 3 again. Well, what happened from the third to the fourth? Well, I went from 9 to 6, which means I had to subtract 3 again. All right, so what was happening from one term to another is they were just decreasing it by 3. And so what I would say is, when they ask me, does this graph represent an arithmetic sequence? Well, yeah, it's decreasing by 3 over and over and over. So I would say, yes, it does. And then it asked me to explain how I know. And I would just say, because the common difference, there's that word again that we learned about in vocabulary, because the common difference is -3. So the common difference is -3. And that's really all we're doing when it comes to identifying an arithmetic sequence when looking at the graph, is saying, those a of n's, what's happening? Is it consistent? Does it happen over and over? Is it common? So I'd encourage you to try example B on your own, then check your answer with mine. So let me move my paper up so we can see example B, and then we'll take a look at it together. So again, it asked me, does the graph represent an arithmetic sequence? Well, it's got to have a common difference. So when I look at this graph, right, again, the first number here just says the number it was position in the sequence. So that doesn't tell me anything. What I'm looking at are these numbers that are second, the a of n's. And I'm saying, what happened when I went from the first term of 2 to the second term of 4? Well, to go from 2 to 4, you have to add 2. Well, what happened when I went from the second term to the third term? So from 4 to 7. Well, I added 3. And then when I went from the third term to the fourth term, right, what happened? Well, I added 4, right? So does this represent an arithmetic sequence, is what we need to figure out. Well, remember, arithmetic sequences always change by a common difference, all right? It's always going to be the same. So as we talked about in chapter 3, it has a constant rate of change. Same idea, right? Well, it's constantly increasing, so there's a sequencing going on, but it's not a common difference, right? It moved from the first term to the second term by 2, but from the second term to the third term by 3, and from the third term to the fourth term by 4, right? So there's not a common difference. And because there's not a common difference, we know that this graph does not represent an arithmetic sequence. So no, it doesn't. And how do we explain that? We would just say, because there is, if I could spell, because there is no common difference. And that's how we explain it, right? Now, you may be saying, well, it was kind of following a pattern. Yeah, it was kind of following a pattern. +2, plus 3, plus 4. So every time it increased in the order, it increased by 1 more than it did the time before. And that's a pattern, but that doesn't make it an arithmetic sequence. To be an arithmetic sequence, you have to increase by a common difference. All right? They have to constantly be changing by a common number, and these are not. All right, well, if you have any additional questions about this, please let me know. But otherwise, you should have what you need to continue on in the chapter.